Good morning. My name is Walter Vergara. I'm the manager of Initiative 20 by 20, a collaborative effort and a platform that groups 17 countries, 80 technical partners, and 23 financial partners. I want to thank you for participating in this event today. We have the pleasure and we have the privilege of having very interesting agenda with participants that are the experts in this field. The topic, of course, is regenerative agriculture and how do we move agriculture from being a carbon source to a carbon sink. It is my pleasure to introduce you, first of all, to Tom Kasten from the Climate Institute. Tom graduated magna cum laude from the University of Colorado in Boulder and was valedictorian at his graduating class at Columbia Business School. He's associated to the Climate Institute. The Climate Institute, of course, one of the first NGOs working exclusively on climate change here in the United States and led by John Topping, who many of you have heard of. Tom was also the founding member and CEO of Free Energy Corporation, has worked extensively on climate issues and the relationship between economics and climate mitigation. He has authored several books and is the author of Turning Off the Heat, a book about why the United States must work on energy efficiency to save money and reduce global warming. Tom delivered passionate testimony to the US House of Representatives on regenerative agriculture earlier this year, and that testimony caught my eye. And I asked him to present some of his findings today at this 20 by 20 meeting. I want to thank him in advance for agreeing to do so. And I want to show you just, well, I'm not able to show, Mary, okay. Let me show you one graph. I want to show you this graph. This is a recent estimate of the greenhouse gas emissions in Latin America in 2017 in million tons of carbon dioxide equivalent. This is based on information obtained from a number of sources, primarily GACMO, CIET, and other primary sources for Latin America. And this estimate concludes that by far, land use is the main source of greenhouse gas emissions in Latin America, accounting, according to our numbers, to close to 57% of the total carbon footprint. So it's very appropriate and very timely that we have Tom talking to us about how do we convert agriculture into a carbon sink. So with that, Tom, go ahead, the floor is yours.
We've got Mary.
Walter, can you please stop sharing your screen?
Yes.
Okay, and now I can share mine. Are we good to go? Everybody
Yes.
see it?
All set, all set.
Yes, all set.
Okay. Well, thank you everybody for joining, and happy to have this opportunity to share the knowledge that I've picked up in the last 2.5, 3 years, looking for the most economical way to sequester carbon. What we're going to talk about is a very quick summary of global warming, just to mention the role of agriculture and what we need to do. I think that we've got a lot of new science that hasn't been around before this century, and things are moving so fast that there's a lot of pieces to it that have changed in the last 20 years, and I'll talk about that. And when I get to the end, I want to talk about the importance of funding these changes, because farmers aren't usually awash in capital. So happy to get to that point. We've got costs rising very much. People talk about we can't afford to fix global warming. We're hitting the costs all the time with frequent storms and fires. IPCC says we've got to sequester an awful lot of carbon dioxide. I've reduced it to tons of carbon, which is easier. We need to do that to avoid the feedback effects. And I just will mention that I think these costs fall disproportionately on farmers. They're the ones that are getting killed by the fact that the climate is changing. The conventional agriculture, since 1850, the practices have sped mineralization of soil carbon and contributed, according to some studies, 35% of human-related atmospheric forcing, perhaps more when we look at it another way. The global topsoil has lost 20 to 80% of its pre-industrial revolution carbon. The soil is just becoming unhealthy dirt. The UN says we've only got 60 harvests left. By 2080, we're not going to be able to grow crops unless we change the practices. So this is a problem all above itself before we ever talk about the climate change. We are increasingly finding that the micronutrients are not in the food that we eat, causing a lot of other problems. I think USDA finds less than half the nutrients in a carrot you buy today versus what it was in 1960. The conventional ag practices are currently contributing this wide range, 20 to 50% of annual human-related GHG emissions. And that's a surprising number, which we'll talk about. We had up to 8% carbon in soils before 1850, before tractors increased tillage. The plowing was used to bury weed seeds, but it speeds the mineralization of the organic carbon into carbon dioxide. Dr. Ratner-Lal has said roughly 35% of GHG since 1850 came from mineralizing soil carbon. Conventional agriculture has also increased the emissions of two very potent greenhouse gases. Methane and nitrous oxide hardly exists except for what we do with farming. I think this leaves farmers in a vicious cycle. They're buying fertilizers and poisons to perform services that a healthy soil would have supplied. We have learned about the role of symbiotic microorganisms, but they are depleted in the soil because of the farming practices. The soil stops holding together, it increases the nutrient runoff. The choice of single crop or monoculture leaves soil bare during part of the growing season, and that reduces the biomass that would have been produced with nature's way, which would have been a polyculture always. Why this 25 to 50% spread? And I'm going to dwell on this a minute. We've gotten a shorthand to talk about CO2, even though those of us close to climate know that it's some other things. So we express the other greenhouse gases in a CO2 equivalent, and it's never, you never see this E100 year, but that's what the numbers are that they refer to. And it's basically, we'll make it equivalent to 100 year. And when you look at that, the 2018 emissions were almost 3/4 associated with CO2 and 20.7 methane and 5.7 nitrous oxide. But if we move to a 10-year CO2 equivalent, CO2 falls to less than half, 47%. Slightly higher, 48% for methane, and 3.4. This N2O number doesn't change too much because it's longer lived. What really happens is the methane only has a 13-year life. And so the 100 years is averaging 13 years of the methane effect and 100 years of the CO2 effect. And I think it misleads, and we need to focus on all the greenhouse gases, but not just on CO2. The thing that really has gotten me going after I retired was this IPCC assessment that says, even if we magically got rid of all the greenhouse gas emissions, the sea levels will still rise over 2 feet by the end of the century. Global temperatures will exceed the Paris Accord limit. And what worries me very much is that every little bit of temperature increases the probability that we're going to get catastrophic feedback. We're already seeing melting permafrost, and we've got the big elephant of the clathrates, that changing ocean currents could boil up some of that methane, and either one of these things in a big way could just change the game totally. So to avoid that, IPC says we got to draw down 830 gigatons of atmospheric CO2. A lot of people are talking about actually pulling CO2 out and storing it someplace, which is a really dumb idea. CO2 is 73% oxygen. There isn't any benefit to sequestering our oxygen. So instead, why don't we just sequester the 225 gigatons of carbon? It's hard to separate, except plants have already done that for us. Plants pull in CO2, they use photosynthesis to separate the elements, then they turn the carbon into hydrocarbon-based plant tissue, and they exhale the oxygen. We have a lot of waste biomass, and it's causing more problems, both intentionally and unintentionally. Farmers all over the world burn piles of straw and other biomass in order to clear the land, which is one of the real big reasons that people in Beijing hardly ever see the sun, or that only, I was amazed to find out that with COVID and all the close down, people in New Delhi could see the Himalaya for the first time in their lives. That's coming from burning biomass immediately. We're having a little extra biomass burning here in the United States, the worst forest fires by far, because we've had so many trees die from pine beetles and there's so much kindling. We'd be better off to convert that into something that's useful. The next point really goes to the whole, what's the best thing to do with biomass? If you burn it immediately, it turns into CO2 and the carbon cycle is accelerated. Left to nature, biomass falls on the ground, and we now know mineralizes in 2 to 5 years. I was thinking on a run the other day, I saw a great big log that had fallen, and it still looked pretty intact, and I thought, well, at 2 to 5 years, except for the big logs. When I turned around and came back, lo and behold, the inside of the log was all hollowed out. Nature was working and mineralizing that material. If you convert waste biomass to charcoal, you're going to mineralize about half of the carbon in the process of burning it. You will get some heat off of it and some other useful things, but half of the carbon is going to go back into the cycle. The other half becomes charcoal. And if we put that charcoal in the ground, then we can change the name to biochar, because it's just charcoal that is not used for burning. And that enhances soil health. It'll stay there for thousands of years, we now know. We argued about that until the instruments got better and we can measure exactly what's happening to that recalcitrant carbon. This helps the plants draw down more carbon. There's a limit to how plants grow according to Justin Liebig's law of minimum. And we've got more carbon dioxide, and some of the climate deniers have said, oh, it's all going to fix because the plants are going to grow faster, except they grow faster only to the limit of the nutrient. By putting healthier soils, creating healthier soils, the plants will grow faster and we'll have more biomass. The big issue is that, and this is a term I have coined, that nature evolved a system to provide free nutrients. And if they do, then you can reduce or eliminate fertilizer and pesticide use, reduce farmers' costs, and increase food production. We'll talk about that a little bit as we go on. This free nutrient system, I've not heard anybody call it that, and I'm sure somebody will object, but we'll describe it and talk about how conventional agriculture suppresses that supply and the role that regenerative ag could have in restoring it, and especially the role that biochar has in picking up the speed of the restoration, and then briefly about the paradigm economics. The thing that's gotten me to wondering is, how did terrestrial plants obtain nutrients for 450 years million years without Haber-Bosch burning natural gas to make ammonia? The terrestrial plants, of course, produce sugar with photosynthesis, but they need a lot of nutrients. I think current estimates are there's 52 nutrients we know about that plants need. And they're all in the soil, but they're hard to get. So we evolved a relationship with microscopic fungi and bacteria. These organisms can't make sugar. They need food. Plants give the fungi up to 20% of their sugar. The fungi then give some of that sugar in a converted form to feed nitrogen-fixing bacteria, which is a very much better way to get nitrogen than to burn natural gas with Haber-Bosch. The fungi form truly immense networks of microscopic pipes. They're one cell big. They reach 100 times the volume of soil that plants' roots reach, and they bring back these nutrients. They secrete enzymes that release phosphorus from the rock. You know, we're all very concerned about running out of phosphorus, but there's phosphorus in the ground if we go back to this system of free nutrients. They then deliver the nutrients to plants, including water. The charcoal that's been left over from wildfires, and there's charcoal in every soil in the soil libraries in the Netherlands. It provides havens with pores that are small enough that some of these microorganisms can live inside of there, but the holes are too small to let in the things that would like to have lunch on these microorganisms. That then helps the population grow, and they're able to do a better job, and you get a healthier soil. So the biochar plays a critical role in keeping them from being eaten. The nutrient system provided all the nutrients for 450 million years. Maybe I've got some of this wrong, and there's people on that I'm sure know those things, but that's where we were. This looks like a big picture, but it's from this wonderful movie on fungi. And this is all blown up. These are the fungi going everywhere. And what also is happening is they're secreting this glue called glomalin that binds together. This is a tiny, tiny little soil particle. It's just showing you how it's getting wrapped up and how fungi can bring these nutrients from all over that. It's very widely used. There's only about 130 species of the mycorrhizal fungi, but they serve about 370,000 species of plants. 92% of the plants use this relationship. So this fungi really serves a lot and connects together for us, and it's a wonderful story in its own. Commend you to the movie. Now comes the problem. The conventional ag suppresses the free nutrient system in a number of ways. Natural prairies and forests are all polycultures. They provide symbiotic fungi and bacteria with food throughout the growing season. There's always some plant that's growing and another plant that's in its dormant stage. But a lot of them connect, and that keeps that healthy. Conventional ag grows monocultures. They provide no sugar after the harvest. Then the soil is left bare, which has some other climate change negatives. And that kind of starves the beneficial fungi and bacteria. So that's the first suppressor. Conventional ag tills the ground. The moldboard plow was an absolutely terrific boon to John Deere. I'm not so sure it helped agriculture. because we can plow deep with big tractors, and we basically destroy all these fungal pipes and connections, and they have to rebuild all that. And a lot of that just simply mineralizes into CO2, and that's why agriculture releases so much carbon. This turns the soil into dirt, and it's been happening for a while. The Dust Bowl came about in part because we didn't have contour rows and so forth, but in part because the soil had been turned into dust. It no longer provides those 50-odd elements that plants need to defend themselves against pests. Healthy plants defend themselves. So the farmers then spray broad-spectrum pesticides and herbicides, and they kill the beneficial fungi and bacteria. So it's all of these practices emerged before we knew this system existed. This was all well underway before people started looking and saying, ooh, it's like your gut. We used to think we ate to feed ourselves. Now we know we eat to feed our microbiome, and that's what feeds us. The soil gets so poor that farmers have to put more and more nitrogen, NPK on the soil to replace the nutrients. There's studies that show we're putting like 4 times as much nitrogen on the soil now as we used to for the same yields. It's a vicious cycle. The soil with shrunken fungal networks now holds less water, really less water, and it suffers more topsoil runoff from heavy rains because the soil particles are no longer bound together, and any little bit of water washes them off and carries it and nutrients downstream, which, as you know, creates some more problems downstream. A lot of bad news from conventional agriculture. Regenerative ag has a role in restoring nature's free nutrient system, and it has a very big role in making the lives better of the world's 3 billion people who exist on farming. 4 changes to conventional ag in the way it's defined today, not the way I would like it defined. You stop tilling the soil, and there's a good movement underway on that. I know in the US, 40% of US farmers have stopped tillage. This eliminates the destruction of the symbiotic fungi mycelium. It enables population growth. I do it in my own garden, and I get unbelievably healthy yields. I don't turn my beds over anymore. You then plant cover crops after the target harvest, and that helps to suppress the weed. You've got a plant there that you can control, and it contributes biomass, but it also provides sugar. After the main crop has come down, it's still providing sugar the way the polycultures in nature provide sugar. You reduce the use of these fertilizers as the recovering microbiome begins to supply nutrients. Without artificial nutrients, plants give more sugar to the fungi, and then the populations keep going. I just make a note on the nitrogen. We are now making 170 million tons of ammonia with Haber-Bosch, and that's putting out almost a half a gigaton of carbon a year. And that number keeps growing, and farmers have to pay for it. We then eliminate the use of pesticides and herbicides as the healthier plants regain their own defense system. Now that's all well and good, except it leaves a problem. The regenerative ag still has to use pre-emergent herbicides to suppress the weeds between the rows of seeds. We just can't afford to have hand labor out there hoeing the fields and picking those weeds, and so we use these herbicides. That means the farmer's got to buy GMO seeds that have been bred to be resistant. And as you know, if the wind is blowing when you put that on, it goes to the neighbor who doesn't have GMO seeds and is not very nice for the neighbor's crop. Those herbicides kill beneficial microbes. And so they keep a completely free nutrient system from returning. Farmers' margins go up with regenerative agriculture, but the yields go down. It requires more land than conventional agriculture, and that puts more pressure on forests and deforestation. So that brings us to biochar, which is the name we give to charcoal that we're going to put in the ground. It has a role in restoring this system. You heat waste biomass in a starved oxygen environment that pyrolyzes the hydrogen and part of the carbon leaving the charcoal. About half of the original biomass carbon is left in a form that will remain for several thousand years. It stays, it's not a fertilizer, it doesn't go away, it just creates things. As mentioned, nature's creating biochar every time there's a wildfire. We've created quite a lot of biochar here in the United States in the last month of August. That charcoal remains the same volume as it was in nature, except now it's lighter, full of all these small pores, and provides the haven for the microorganisms, prevents the predators from eating it, and allows the population. This is mentioned again, this glomalin that was discovered in 1996. It has a life in soil of 4 to 7 years, longer than regular biomass, but perhaps longer because it locks up little particles of soil and it increases the population of the fungi. That glue is what really matters from a climate change point of view. This is a long subject over my skis, but the biochar surfaces enable an ion exchange that allows all kinds of nutrients to shift into a form with an extra electron or an electron missing that makes it a form available to plants. Very important. This is what biochar looks like. It's been ground up a little bit. This is what it looks like under a microscope, and those are very, very fine pores, and little tiny microbes can get in there, but the little bit bigger things that eat microbes can't make it in. And then you've got this just mat. And remember, all of this has got this glue around it, which keeps it from getting eaten so much. Here's the cycle. You start with biomass, and I would emphasize waste biomass. You run it through pyrolysis, and 50% of that carbon comes out as biochar, and it's got a life that is beyond what we need to worry about. Some of the rest of it can turn into syngas or bio-oil, but in the end, 50% of the carbon is going to get back into the CO2 cycle pretty quickly. The syn oil can create some wood vinegar, which people in some parts of the world are very anxious to get, and that's creates some additional revenue from this process so that we can do all this without having to have subsidies. And the chemicals in the wood vinegar can be turned into sprays that stimulate plant growth and ward off all kinds of predators without killing. It's sort of an organic supply. What are the economics of regenerative ag with biochar? Well, first of all, and I think everybody is sort of missed on this one, it's an investment. It's not an expense. When you put nitrogen on the ground, it's an expense that you pay for this year's crop. Next season, that nitrogen is gone, or whatever other chemical. When you put biochar in the ground, it's going to continue to yield benefits for centuries, which those of you that know about the Terra Petra soil in Amazon, 500 years later, it's still very fertile. There are some flaws in the conventional research, and this is a problem that, I've had people say to me, well, this was hyped before and we've already looked at biochar. Raw biochar doesn't help the ground in the first year. It needs to be marinated with manure or compost to load up on nutrients and eliminate the waxes that block the pores. Many, many trials have gone out and put raw biochar on a particular kind of soil with a particular crop, and at the end of the year found that the yields were either the same or less with the biochar, ended the experiment and concluded that that didn't work. A few trials had the funding and the persistence to look at the second season, and lo and behold, yields started growing in the second season and the third and the fourth. I'm having trouble finding any trials that go beyond about 8 years, but at the 8-year mark on the trials I found, you still have a pronounced effect from having put biochar on the ground. I understand scientists want to control one thing only, and so they don't like to do this. Commercially, almost nobody uses raw biochar. They put it in compost and let it marinate for a while, and then put it in the ground. One of the key advantages is the haven that biochar provides to increase the population, but as noted, conventional agriculture throws 5 different things at the microbiome to hurt it. And so we don't really have a good knowledge of what biochar can do from us in a regenerative ag yield. I don't find studies that are looking at what a regenerative farmer is doing and then see what happens when he adds biochar. We do see some evidence when commercial people have done this, but it's not the kind of peer-reviewed science we'd like to see. When you add biochar to perennial crops, you begin to get proof of what I'm saying. Perennial crops are intrinsically no-till. You don't plow up your grapevines every year, and we've seen grape production rise by 100%. You don't plow up sugarcane for 5, 6, 7 years, depending on how you do it. And in the paper, I've got a trial that was done in Louisiana for the last 5 years. And the investment in the biochar, with nothing else changed, yielded a 70% per annum return to the farmer. That's really phenomenal. Tests in Nepal with bananas found the same thing, 100% increase in the yield. But in these cases, we're not tilling the ground and probably not putting on the same pesticides, and hence we're enabling the symbiotic functions to do what they were evolved to do. This is a picture of the sugarcane trials, and I want to walk you a minute. This is the first.
We have 3 minutes left. Is that okay?
Say again, please.
We have just a few minutes left.
Okay, I'll go fast.
Okay.
The controls on sugarcane drop every year after it's planted. With the best biochar, they start higher and they go even higher. Just really terrific. Feed it to cattle. Doug Powell grazed 60 cows on his avocado farm. He's increased his margin by $45,000 per year, $750 per acre by feeding about 0.6 of a kilogram to his cows. We need to speed the deployment of profitable sequestration, and that's going to take financial engineering. You've heard about the investment quality, but a lot of the world's farmers don't have access to capital, and they can't take risks. If their crop fails, their family doesn't eat. This creates opportunities for impact investors to create financial mechanisms where they loan the money and take some of the risk, but give a lot of the benefits back to the farmer. I think this is exciting, and I'm asking the question to those investors, is that something that's interesting? Regenerative ag can mitigate climate change and avoid the negative feedbacks that we're worried about. It's going to take multi-trillion-dollar investments. It could yield 20% Mother Nature returns or higher. It could cut CO2e by 70 to 100 parts in 20 years. The addition to the soil will also cut methane and nitrous oxide emissions. The health will trigger a positive feedback loop, more biomass production, and there's a lot of other benefits that you can read, including reducing forest fires by cleaning that material out and turning it into charcoal. Eliminate the dead zones. So in conclusion, this is new knowledge. It opens up a no compromise path. We don't have to give up standard of living in order to mitigate climate. We can have both. A lot of other benefits thrown in. The global warming costs fall disproportionately on farmers, especially subsistence farmers that are just, they're starving because their land is being desertified or they've got floods or whatever that wipes it out. If we convert about 40 to 50% of the world's current waste biomass to biochar, we could sequester enough carbon to keep the temperatures from exceeding the Paris Accords. This is a work in progress. I welcome the comments of others in the belief that we can improve, and just want to say to you that moving to regenerative agriculture is a significant benefit. If you've got a better plan that'll sequester carbon, please speak up. If you have a plan that'll only do it with government subsidies, you don't have a plan. Please consider trying to encourage this. Thank you.
Thank you, Tom. Very interesting, very thought-provocative. I really enjoyed the presentation and I learned quite a few things I was not aware of. We have two great commenters on your presentation. The first one is Mary-Ann Nyopiang. She's a researcher in forest ecology working for CIRAD in the Research Unit of Forests and Societies, and is an associate scientist posted in CATIE. Mary-Ann holds a PhD in forest science and modeling from Agro Paris Tech and a master's degree in ecology from the University of Paris. She has a scientific background in plant biology, physiology, agroecology, ecology, and modeling, and therefore a fantastic, well-suited commenter on your presentation. Go ahead, Mary-Ann.
Thank you so much, Walter. What a great introduction. Thank you so much, Tom. I really enjoy your presentation and the document you sent. It is very interesting for me as scientist. I'm scientist of CIRAD, which is the French Agricultural Research and International Cooperation Organization working for sustainable development of tropical countries. Then I'm also an associate scientist in CATIE, as Walter said, and which is a research and tropical agricultural center based in Costa Rica. Both are technical members of the initiative 20 by 20, and CATIE is a founding member of the initiative. Then we are definitely interested in related thematics, thematic related to your talk, climate change, of course, adaptation and mitigation, biodiversity conservation, because you were saying killing soil, killing fungi, then your technique also aims to preserve, to conserve that biodiversity in agricultural soil. And it is also related to biodiversity and the benefits in agriculture. We are also interested in familial agriculture because you mentioned in the document it is well documented, the example of Terra Prieta, for example, where you say that native people in Latin America, but also in Australia and Africa, were producing biochar, and it was related to an improvement of yields. And in both institutes, we are very interested in promoting local knowledge. Also, you are talking about nutrient and water cycling, and it is definitely related to ecosystem services that should be improved in a more sustainable agriculture. I will say that your paper and your presentation are definitely related to what we can name smart climate agriculture, which is defined as climate smart. Which is defined as an approach for transforming and reorienting agricultural development under the new realities of climate change. I'll be interested to read more about regenerative agriculture because unfortunately I did not find many literature in your doc, but I'm very interested to find some. I think I will. I will be interested to see, for example, the increase or the non-decrease in yields compared to conventional agriculture, which is very important for many smallholders in the tropics. They are more or less aware of climate change, and they are definitely aware of the importance of maintaining yields. Any study comparing regenerative agriculture using biochar to other alternatives to sequester carbon. Also, I would like to discuss about agroecology, because between Serran and Cartier, we have been working on agroecology that has a lot of definition in literature. It is defined as ecology in agriculture, the science of sustainable agriculture, and it's aimed at promoting increasing ecological processes in sustainable agriculture. Then I will have some questions for you. Then what will be the difference or the similarities between regenerative agriculture and agroecology? Because when I'm listening to you, you are definitely talking about agroecology, how to naturally, and then in an ecological manner, how could we increase natural regeneration of natural implementation of ecological processes in agriculture, in degraded agricultural system. It is also definitely related to restoration, to ecological restoration, then give to a degraded soil a manner to recover some ecosystem services. Then what will be what do you link, how do you link regenerative agriculture to agroecology? And how do you link regenerative agriculture to ecological restoration? If I have the time to, I have a third question. You have been working with politics. You are board member of the Climate Institute, and you have been in contact. You are member of the Committee on Climate Change of the United States of America. And as you said in your paper, there are credits, community credits to pay farmer in order they grow corn and soybean. And we have the same thing in France, for example, where farmers have they have credits to produce wine, for example. And then how could we, what will be the next step? How could you convince, since you are close to them, you discuss with them, how will you convince these politics? How will you engage these politics in order to improve in order that they account to scientific conclusion when they are taking decision about our environment, in order, I will say it better, in order to have political decision, especially accounting for environmental policies.
Thank you, Marie-Ange.
So much for your opportunity, and thank you, Walter, for the invitation.
Thank you, Marie-Ange. Tom, very quickly, 2 questions. You are in the midst of political turmoil in the US. How do you see the next steps to move the political agenda toward support for regenerative agriculture? And the second question, the linkage with agroecology and ecological restoration.
What I hope to have done is to summarize this incredible growth of knowledge in language that lay people can understand a little better than reading scientific reports. because it's information that gets it done. We have an agricultural policy in our country that is strongly rooted in completely obsolete science. It was done with the best interest. We pay $25 billion a year to farmers to do these destructive methods. With respect to bringing it to ecology, I think we have a lot to learn there, but what we're seeing is farmers that have embraced on this are going back to planting polycultures between their rows. They're finding healthier crops. They're grazing cattle differently. And they're trying to bring young people back to the land where they feel like they're doing something good rather than just making a gazillion tons of soybeans that go off to a feedlot someplace. So I think it's knowledge and information, and we're starting to get that. My son is a congressman and has been introducing some of these ideas to the other people on the select committee. And it's an education process. The point I would end with is we're out of time, folks. We have to get this done right away.
Thank you, Tom. Thank you. And now I have the pleasure, the immense pleasure of introducing Ruben Echeverria. He is Director General Emeritus of the International Center for Tropical Agriculture. His work on agriculture, environment, and rural development issues at the Inter-American Development Bank, where he was the Division Chief for Agriculture, the Science Council of the CGIAR, and at the Latin American Center for Rural Development. Ruben is currently a Senior Research Fellow at IFPRI in Washington. He chairs the Scientific Advisory Board of the Catalan Institute of Food and Agricultural Research and Technology. But more than that, I think Ruben has been a pioneer in sustainable agriculture. And as a person, he was one of the driving engines behind the initiation of Initiative 2020. Ruben, the floor is yours.
Thank you, Walter. It's a pleasure to be here. Thanks for the invite. And thank you, Tom, for the paper, Marie for the comments. I also saw one of the star research directors of CIAT of my times, Marcela Quintero. I think she's joining us. So I will be very brief because the experts are all here. I have three comments to make. One is the general, I think time is of essence to pick up on Tom. So I think we should put all the tents together. There's no one regenerative, one agroecology, one sustainable agriculture intensification. There are many churches and many schools. I think because of time of essence, to follow the author of the paper, I think we should converge. We should seek synergies and we should go for it. Because the more you go into agroecology or regenerative agriculture, as the Australians call it, and many others, the principles are the same. Many centuries ago, I used to be an agronomist and I did my thesis on soil. So I really had an emotion to see the PowerPoint from Tom, all the good things that I already forgot, but now they are refreshing my mind. So I think that's also another reason why in 2 weeks in Iowa, the World Food Prize will be given to a soils scientist. So it's all about soils and research. And finally, people are discovering that there is organic matter in the soil, and that's a lot of carbon. So it's fantastic to have that. Within this first point, sequestration is key, and regenerative agriculture is fantastic, and biochar is one fantastic practice to do. But I think we also need to adapt. It's not enough to think and mitigate. We need to adapt. So I think this is part of a menu which is very broad. So it should not be, and Tom didn't do it that way, but I think it should not be taken as a one silver bullet to fix the world. The world that Tom starts the paper in 1850 had the population of India today. So the world has changed a lot. We multiply by 6 the number of people. I'm not justifying John Deere, but Tom, but I think the world has changed a lot, and there is a lot of people that they are not well fed. And so there is a huge change in the transformation of these, as we call it today, food systems. So this should be part of a large set of practices. My second comment is more on the details and so what, the key question, so what do we do? And first of all, not all farms and not all farmers are equal. So if you're talking about a 5,000 hectare soybean farm in the Pampas of Argentina, of course, is not the same as 1 hectare near Addis in Ethiopia, right? So to target, this is all around the political economy and how we do research on tropical agricultural systems. How do we target this to continue the great work of Tom on informing the public on how to do it? So it shouldn't be a one biochar solution for all conventional agriculture, because more than half of the world still is not in the conventional agriculture that we want to regenerate and change. There's still a huge yield gap in the global south, a huge. From the research stations that you can see at beautiful CIAT in Palmira, Colombia, you just cross the street and look around. Those yield gaps are claiming for a huge best practices, agronomy, minimum tillage, rotation, crop pasture rotations, you know, you name it, everything, some of them were mentioned there. I think we need a lot of innovation. We cannot bring back minimum tillage. It's a fantastic thing and we should, of course, scale it, but there has to be innovation. And I like the very punchy sentence from Tom that the science is obsolete. Yes, yeah, we need, hence, I think part of the political economy, Tom, in Washington is to try to convince how to transform those subsidies for the old science to investments in agricultural research, particularly in tropical agricultural research, which is, I think, where the big demands are. What's the scale of this? What are the big investments that we need? I think we need the metrics. It's not enough to say that we have fungi and that we have biochar. I think we need to, and Tom is really getting into the numbers. I think we should work on the metrics. Otherwise, you know, today you can just Google in your phone and find out key elements to make an argument. So we need more research, and thanks that Marcela and Maria are here from the research community to do this. Without that, if we do this rotation, we are going to sink so much, we are not going to convince people to invest the billions that we will need to do that. My third and last point is just based on a very recent document that one of the STAR programs of the CGR called the Climate Change, Agriculture, and Food Security put together. Is a recommended reading. Put it under your pillow if you can. I will send the link. Marcela was part of that study, and they have 11 actions very related to this presentation. So I'm not bringing something from the moon. And I just want to mention 5, just the titles, Walter, because we don't have time. One is how do we not only change the regeneration, but how we decrease the agricultural expansion in the high carbon landscapes. We need to check what happened with the high carbon landscape, because we have a lot of landscapes that are not degenerated that we need to keep. Also, how to increase the climate resilience and low emissions practice. There's a lot of low emissions practices. I've seen a lot of great research, but we need to put it on the ground. That takes a lot of money, of course. How to transform the diets and the food systems to reduce emissions. So it's not only to sink more, but also to reduce. And a big one for me is how to subsidize the transformation. The 25 billion that Tom mentioned, you know, the entire group of centers in the international community called the CGR is 1.5% of total agricultural research. It's nothing for the huge impact that the CGR has had. And WRI, Walter, and Marie, also Sirad and Kathy, of course. But so I think for those big numbers, if you can transform that restructure, that support, we are on. That will unlock the finance for farmers, as Walter and company in the 2020 initiative have masterfully done, to how to bring the pension funds, the impact investors into this. The argument on biochar is fantastic. I'm not going against and say biochar is part of it. If we expand the menu, we get more investors. And then I end with the obvious coming from Ruben. If you don't strengthen agricultural research and extension, and you don't strengthen capacity at the national level, not at WRI or CIRAD or CIAT, but at national level, we won't get there. We won't get to the 1 trillion tons of carbon to be sequestered. Thank you very much. It's been a pleasure to be here. Thanks.
Thank you, Ruben. And then let me introduce you to Marcela Quintero, who will moderate the question and answer session. We don't have many questions yet. I hope that you guys are sending your questions to the chat. Marcela Quintero works for the Alliance between Biodiversity International and CIET. She's the research director of multifunctional landscapes research. Marcela is an ecologist, holds a PhD from the Department of Agronomy at the University of Florida. Her work experience has been on research, product implementation in thematic areas related to payment for ecosystem services. Marcela has worked as well for development organizations like GIZ, Condesa, and Forest Trends. Marcela, please take it over.
Thank you, Walter, and thanks, Tom, for really this good presentation and also the paper that you shared with us. And thanks, Walter, for this invitation. And I'm very happy to see here my ex-host, Ruben. It's always good to see you. And Marie, nice meeting you. I would like to start, we have one question on the pod, so I will just read the question to Tom. And then after that, and after we receive more questions from the participants, I would like also to provide some comments on some questions from my side. So Tom, we have one question from one of the attendees that is for you. And have you ever heard of Ramial chipwood as a methodology to restore the trophic chain in the soil?
I'm not understanding the word you're saying.
Ramial, yeah. Ramial chipwood. It seems like a type of timber for restoring the soil.
I need some help on what you're asking, Ruben. Or
Yeah, Tom, it says the question is, have you heard of Ramial chipwood as a methodology to restore the trophic chain in the soil? I don't know what that is. I haven't heard of it, but Tom, go ahead.
I'm not understanding the first word. I hear chipped wood. Wood, of course, is a great feedstock for biochar, and you can make it out of a lot of substances. If we're referring to recycled wood, yes, that's very much a possibility, and we're actually doing it in some plants where the construction waste comes in and that wood gets recycled and made into biochar, but I'm not sure I'm answering the question.
Okay, thanks, Tom. And if probably the participant, I think, can reach you later if we'd like to go deeper on this. And there is another interesting question, and it's more about extension. And I think Ruben touched bases on the need to keep investing on agricultural research, and I think definitely it's a need. But also there is another face of the coin, and it's the extension services. So from your experience, and at least in the US, how do you see extension service, how they can improve to really getting the word out to the farmers?
I see some of the best things happening coming out of that extension service. These are incredibly dedicated people who chose to do something with their life that they thought was going to help the world, and they travel around, and we've got some stories of them just doing seminar after seminar and saying to a bunch of assembled farmers, I'm not going to tell you what to do, but what you are doing is hurting the soil. Here's what you can do to do it a different way. And that's the kind of information transmission that the farmer listens to. Sadly, a very wonderfully drawn research paper is not probably going to be read by a farmer deciding what they're going to do. But when they can talk to this guy that's wearing a plaid shirt and walking around in muddy boots, there's a respect. Very, very important. And I agree with the comment earlier that we need to recognize that knowledge is growing way faster than it ever grew before. It used to take 100 years to obsolete knowledge. Then it was 25 years after the war. Now, some knowledge is changing overnight. We're packing up data. They say that an engineer leaves school and within 5 years, half of what they learned will have become obsolete. I mention that because this explosion of research in the 21st century is what's underlying the understanding of how we change. So how are we going to get that promulgated except with extension agents that learn it and take it on? Very important.
Thanks, Tom. And I think this is also for Ruben. Ruben, I have a question regarding what could be those other alternatives in addition to the biochar that you were referring to. Probably you can give some examples so we can, as you say, give a menu to restore the soils, to regenerate those natural functions of
Sure.
soils.
Thank you.
And that's one thing. And the other one is you can provide the link to the 11 points that you were mentioning.
Okay.
That will be useful. Yeah.
Okay, I just put the link to the Commission on Sustainable Agriculture Intensification. And as soon as I have a moment, I will put the link to the CCAP's report. Otherwise, Marcela, you also have it there. It will be nice to, I mean, as a reference, it's good because those broadens the menu. On the question, I think in addition to what Tom says on the extension, most extension agents or extension services as we knew it in the Green Revolution times evaporated. They don't exist. So today, I think the innovation will be to bring the private sector, civil society, and others to make good so-called extension, which is now is part of an innovation system. It's not linear anymore. But anyway, I think they could provide a measure because if it is as profitable as it looks as it is, there is room for everybody here, not only the good old public extension agents that I think in the Global South, with some exceptions, they are not that common anymore. So the private sector, the new John Deere's of the future, Tom, is still selling the moldboard plow. They can be innovating on this and everybody it will be a win-win-win. Anyway, so that could be one. On the menu, well, I refer to the good agronomy, going back to 3 or 4 major practices on not destroying the soil, doing rotations. People forgot about rotations. They're still very common. In the tropics, you have 2 or 3 harvests per year. That's a rotation. In the temperate areas, you have a lot of rotation crops and pastures. Most of the good soils that are not degenerated yet are normal pastures. I'm coming from a little livestock country, so I seem to have some good examples there. There are many more in the tropical belt, Walter, that you have worked in the World Resource Institutes and others. So the agronomy covers many things. The research today that I was referring to that we really need to invest is not academic research. That's great to have academic research. I'm talking about the applied research for development in the tropics on agricultural systems to really bring back what we learned from the old science or new science into these innovation systems. For example, there are 2 big revolutions going around, the life science revolution and the digital revolution. If you combine the 2, that's the new extension. That's where you can innovate. And the coffee farmers in Colombia, which is a fantastic group, can look in their telephones and see what's going on with biochar for coffee. That could be a market dimension for all of this to be concrete. The same for others, sugarcane and many other things in the tropics. I am very concerned to finish on the small farmer because I think we have this very nostalgic, emotional view of the small family farm with in Africa, very happy and smiling with somebody comes and take a picture for the annual report. I think that small 1 hectare or less, or 1.5 hectare or less, is in transition, and we also need to help that transition, perhaps to move out of the farm as our ancestors did. All of our ancestors came from a farm. I can prove it. So anyway, I'm not saying that we should push everybody out, but I'm saying that some of these solutions like biochar may apply at some scale or larger, but not a small scale. At small scale, the more you go small scale, there's a lot of agroecology, Marie, going on at small scale, and much less at the bigger scale. So all of these trade-offs need to be quantified, and that's why research is very important. I hope from all of this conversation and future dialogue, some of these impact investors, Walter, not only will invest in do reforestation, which is fantastic, hopefully more on biochar, which is also fantastic, but much more on the research, on the real research on the ground, not academic, not for papers only. I think that's much needed. And Tom alluded in the last 3 slides that he went fast. I think there is quite a bit of a research menu there, Tom, to follow up with good investments. So I'm sure Marie and Marcela, which are on the ground, can chase some funders to do that in the next few years. Thanks.
Thank you, Ruben. And I mean, going back to this question about the menu and so on, there is an interesting question from someone today here, and they said, yeah, there are many different practices, but biochar is one that is very holistic in terms of the value that it provides, because it reduces waste streams, it sequesters carbon for generation, it provides a safe microbiome for the microorganisms in the soils, and so on. So probably this is also for Marie and for Tom. I mean, is this only biochar, the few ones that can provide these holistic values as a practice, or do we have evidence on other kind of practices that we can incorporate to the menu of regenerative practices?
Okay.
So probably Tom and
I appreciate that comment. And I think one of the things that excites me is that biochar can be made in a tiny little stove. If you replace a 3-rock stove of a 1-acre farmer with the stoves that have been developed, they burn half the wood that they're burning right now in a 3-rock stove to cook the same food, and they get charcoal out of the stove as a return. Unfortunately, a lot of places, they're buying the charcoal to sell to somebody else as a fuel. But putting that charcoal on the land, there's very simple ways to make biochar the way it was made in Brazil. You know, just a hole in the ground and you smother it and so forth. There's also some very sophisticated ways to make it. But every place there's agriculture, there's waste biomass. And bringing that and getting it into the soil and getting it to be gradually grown. I want to make a quick comment about the extension that Ruben talked about. We see this happening. There's an organization called Indigo, which is advising farmers with very precise information and spreading it and telling them, automatically respacing the seeds in a crop based on the soil. There's Land O'Lakes does it for their farmers, but what's kind of more back to the little farmer, we've supported an organization for the last 12 years called 1 Acre Fund that serves 1 acre farmers in Africa, mostly women, and just showing them a little better methods and so forth. I'm in a lot of conversations with them because they can introduce this. They have enormous credibility with the farmers, and that's a way. He's serving 1 million farmers and about 7 million people right now, and expanding at 50% a year. So there is a way to get the information out, as you mentioned. They can see on their phone what they need to do, and we really need to encourage that.
Thanks, Tom. I mean, I think we have to wrap up soon, but I think there is also one topic that I think deserves another hour of discussion, that is the economics behind the biochar. So have you found evidence in terms of how the benefit and cost ratio change when you apply biochar into a large commercial agricultural farm versus a smallholder farm? I mean, do we have a clue on that, or is something that actually we as researchers have to start answering? And I'm sure that there were also questions around that in Indeed.
I want to come back to that, because what I have found that excites me is sugarcane, especially with respect to some of the audience here in the, Latin America, a lot of sugarcane. Biochar was made with the leaves, which are a problem. The mills have trouble getting rid of the extra bagasse. They put that in the land one time, and over 5 years, they got steadily increasing returns. And then they plowed the land at the end of the 5 years, because that's the way they always did it. But the land was committed. It probably could have extended that cycle of letting the sugarcane maybe grow 8 or 10 years. It looks like sugarcane could produce the same amount of sugar that is now being produced on 50% of the land. If you factor that in, that takes the pressure off of deforestation, because we're growing the crop on less land and we don't have to tear forests down. The economics are profound. The biochar economics on row crops where we're plowing the soil are not very good. And I take from that some anecdotal support of the thesis I put forward, that those conventional things are blocking the very benefits that the biochar is trying to bring. So it's this going on instead of let's work together. Hope that's answering the question.
Can I add one thing, Marcela, on this topic, very brief. So one idea, sorry to be provocative, but anyway, it's around noon here in Washington anyway, and we have elections coming, Tom, in a couple of months. So why don't we have an initiative where WRI, Biodiversity CIAT, and CIRAT CATIE, that's a fantastic tripod together, with some funding that perhaps in your next conversation with senators, Tom or others, or your son, or others could have a small initiative to pick on this point on the economics of biochar, because small farmers don't grow sugarcane, with some exceptions. So if we go to the ag systems in the tropics and we have these economics, and I'm not talking to do a PhD thesis on the economic, I'm talking to go on the ground quickly with the data that we have. That will be a fantastic initiative to follow up this conversation, Walter and company. I think because we have the research talents, you cannot do research without researchers. We have the researchers here, we have the organizations, and people are coming back, thanks to Indigo and others. People are coming back and say, yes, yes, we can do a lot of this in the temperate areas, very well measured, but not in the tropics. Perhaps we can adapt and adopt some of these great technologies into the tropical and expand what 1 acre is doing. 1 acre at a time is fantastic, but we have a lot of acres to go. So with more funding, perhaps this is an initiative. Sorry, Walter, to give you more things to do, but I'm sure that Marcela and Mary doesn't have anything else to do anyway. So with this new funding that may come, they can really put some good black and white numbers on this topic. And that will strengthen the argument. Thank you.
Ruben, thanks a lot for the very provocative comment. And I want to thank Tom Kasten for this wonderful presentation, and also for the pioneering role that the Climate Institute has played in this country and internationally. And as Ruben alluded, you are one of these NGOs that has been able to insert itself, pushing politicians to do the right thing. So my hat off to the Climate Institute, to you in particular, to John Topping, for all you have done in the past and continue to do. Thank you, Tom. And I want to also thank the commenters, Mary Ange and Ruben. Fantastic discussion. And with Ruben's suggestion at the end, I think we have an agenda to continue on the topic, and I enthusiastically endorse your suggestion. And let's discuss with CIRAT and CIAT and the Climate Institute how we move forward. To Marcela, many thanks for the moderation. It was great. Thanks a lot, and it was great to see you. And Mary, thanks for organizing the logistics, and to all participants we have stayed faithfully during this period. Many thanks. We'll post Tom's presentation at the 2020 website, and we'll continue discussion with Tom and with CIRAT, with IFPRI, and with all others in the future. So many, many thanks to you all.